Let's start out with a trace file called tr-malaysianairlines.pcapng. And in this trace file, we have someone who is going out to the malaysianairlines.com website. Now, we have to deal with the coloring that we're seeing in this trace file first. You'll notice that we have a number of packets here that are colored with a black background and a red foreground. And that includes our first DNS query going out for www.malaysianairlines.com. Now, anytime Wireshark gives you a black background and a red foreground, it's trying to call your attention to that packet for some reason. And if you ever want to know why a packet is colored a certain way, simply select that packet, and we can see right away that there's something in the IP header that's a problem. But if you want to know what coloring rule that packet matched, you can expand the frame section of that packet in the Packet Details pane. And in the bottom of the frame section, you'll see an area that indicates the coloring rule name and the coloring rule string that the packet matched. So this packet has matched the checksum errors coloring rule. And we can see in the IP header of packet number 1 that Wireshark is indicating the IPv4 header checksum value is incorrect. It also indicates that this may be caused by IP checksum offload, and that is the case in this trace file. This trace file was taken directly on the host 192.168.1.72, and that host supports task offloading. That means that at the time when Wireshark is getting a copy of the outbound packet, the checksum has not been calculated yet. That's not going to be done until that packet gets down to the network interface card. And we know that the checksum must have been good going out onto the network because this DNS query with transaction ID number 8AF7 did receive a response. If the checksum were actually incorrect when it went out onto the network, we would not have received this response. So we know that we have task offloading taking place. If we want to, we can disable the IPv4 checksum validation process, or we can go in and just disable the checksum errors coloring rule. I'm going to disable the IPv4 checksum validation process. Simply selecting the IP header inside the Packet Details pane, I'll do a right mouse click and go to Protocol Preferences and then turn off Validate the IPv4 checksum. There. Now we can see that validation has been disabled and we're not going to get distracted by these false positives. Now looking at the DNS traffic, we can see that it's now gone back to this light blue coloring. And DNS traffic doesn't have its own coloring rule in Wireshark. Instead, it uses the UDP coloring rule if it's sitting on top of a UDP header. So packet number 1 and packet number 2 are colored with this light blue background. And in the frame section of those packets, if I expand it, I can see that the UDP coloring rule is being applied to the DNS traffic. I'd like my DNS traffic to be a different color. A little bit later, I'm going to make another coloring rule that will highlight DNS problems. So let's build a new coloring rule for just DNS traffic. I clicked on the Coloring Rules button up here in the main toolbar, and I'll select New. And my new coloring rule will be just simply DNS. Coloring rules are based on display filter strings, so I can just type in DNS, which is the display filter that I'm interested in. And I'll set the background color to, well, if I just type in green, Wireshark will change that over to its hex value, and that's a little too bright. So maybe I will say light green. And that looks a little bit better. I'll say OK. And the name section there gives me a preview of the coloring. It's very similar to the coloring that we see when our display filter value is correct. I'll say OK. My DNS coloring rule has to be on the top here as well. If I had placed it below UDP, the packets would still match the UDP coloring rule because packets are processed in order. So I'll keep it up on top and say OK. Now I can see that my DNS traffic is colored with that light green color that I selected. Now let's just look at the DNS traffic in this trace file. I'm going to apply a display filter simply for just DNS. Here we can see there's a DNS query and a DNS query response. The transaction ID numbers match, so this response in packet number 2 is the response to the DNS query in packet number 1. We see 3 queries go out in the row, and then we start seeing some responses. Looking at the time values for these packets, the time column default setting is to show us when each one of these packets arrive compared to the first packet in the trace file. And oftentimes I will change this time column. I will set it as view, time display format, and second since previous displayed packet. In this case, after I set that, the time values are not going to help me out tremendously, because if I look at the time value on packet number 24, it's telling me how much time transpired between the end of packet number 20 and packet number 24. Well, packet number 20 is a different transaction ID than packet number 24. Those two packets are not related. If I'm interested in looking at the time from a DNS query to a DNS response, then I'm interested in looking at the DNS time field. The DNS time field resides inside of DNS responses only. Inside of frame number 24, I'll expand the DNS section, and the second line down there is the DNS.time field. If you move the status bar column over a little bit, you'll see a description where it says the time between the query and the response, DNS.time. This field is in brackets, which means the field does not actually exist in the packet. We can right mouse click on that line and say that we want to apply this as a column. We now have a column that's showing us the DNS time value. The title of the column is pretty generic. It's just time. So I'm going to change that column heading. I'll right mouse click on that column heading and go to Edit Column Details. And in the Column Details title area, I'm going to type in DNS time. So now I can tell what that column is for. Now that I've added this column, I can sort this column to find the highest DNS response times in the trace file. I'll click on that heading twice and then jump to the top of the trace file to see what the highest response times were. It looks like we have 492 millisecond response time at one point and 400 millisecond response times. These are not very fast response times compared to what I'm accustomed to on this particular network. So those are not very good response times at all. I can use that DNS.time value to create a filter. Maybe I'm interested in always being able to see when the DNS response times are greater than 1 second. If you wanted to look for DNS response times that are greater than, let's say, 600 milliseconds, you can put in .6. If you're looking for greater than 632 milliseconds, it's greater than .632. But I'll look for DNS response times that are greater than 1 second. I'll apply this filter to the trace file, and we already know that none of the DNS response times were quite that high. But this may be something that I'm interested in looking at. Maybe I'll change this to 500 milliseconds by putting in DNS.time greater than .500. I'll apply it to the trace file, and we didn't have any that were that high either. But I'm going to create a button out of this filter so that I can quickly detect any time the DNS time is greater than 500 milliseconds. Once I've typed in this filter, I'll click the Save button, and Wireshark will prompt me for a label for my button. And I'm going to say DNS greater than 0.5. And I'll click OK. There's my new filter expression button. If I clear the filter out that I had in place, and I'm working in the trace file, let's just sort by its original order. I open up a trace file and I want to quickly know, do I have any DNS response times that are greater than 500 milliseconds? I can simply click this button now. And if there are any packets that do match that filter for that button, they will show up. But what if you wanted to change that filter name? Or maybe you wanted to delete it? In order to change the filter name or delete it, we have to go into our Preferences area. So we'll click the Edit Preferences button on the main toolbar. That's the screwdriver and the wrench crossing each other. And in the Preferences window, on the left-hand side, you will see a section for Filter Expressions. There's my DNS greater than 500 milliseconds name. I want to put a space on either side of that greater than symbol. So once I put in the space, I'm going to click away from that area to get out of the edit mode, and then simply click OK. And there's my edited button. The last thing we'll do is we'll create a coloring rule based on this filter. So if we're just looking through trace files and we didn't click the button, our attention would be called to a packet because we have a high DNS response time. So selecting this filter, I'm going to copy it into Buffer, and I'll click on my Edit Coloring Rules button. Now we already have a DNS coloring rule that we created, but we'll create a new coloring rule for DNS high delay. So in the name area, I'm going to call it DNS Delays, and I'll just put in that greater than 500 is what I'm looking for, greater than 500 milliseconds. I'll paste in that string that we have in the background that we used for our filter expression button. I'm going to set the background color to orange since I use that as my but ugly color. And I'll say OK. There's my orange. Say OK. And I will leave that coloring rule at the top because I want to make sure that if DNS responses came in greater than 500 milliseconds from a DNS request, it's colored orange. I don't want to move it below my DNS coloring rule. I'll just say OK and then clear that out. Let's test this new coloring rule and the filter expression button on another trace file. I'm going to open up the trace file called tr-dns-slow.pcapng. And right away, you should be able to see that we do have the bright orange coloring showing up on a DNS response. We can sort our DNS time column and pop to the top to see where the largest delays are, and there it is, a 1.29 second delay on this packet. We can also just simply click on our DNS greater than 0.5 button, and there's the largest DNS delay in the trace file. So it's a combination of using filters, using coloring rules, and using filter expression buttons that can help us quickly detect when we have DNS delays. We can also add that column, which is great, that column that gives us the DNS time value, and by quickly sorting, we can see the highest DNS delays in the trace file.